In 5C, we want to find the polynomial of least degree with integer coefficients and a 0 at 2 plus 3i. Because these zeros have to happen in conjugate pairs, that means we know that there's another 0 at 2 minus 3i. So, setting up the polynomial, since one 0 is at 2 plus 3i, its factor is at x minus 2 plus 3i. And since another 0 is at 2 minus 3i, its factor is at x minus 2 minus 3i. And we have to multiply this whole thing out. But there's a little bit of a trick to it. First of all, what we should do is rewrite what's inside of each set of parentheses by distributing the minus. So we'll have x minus 2 minus 3i. And in the second factor, it'll be x minus 2 plus 3i. Now, you can go ahead and brute force this by distributing the x minus 2 minus 3i to each term in the second factor, and then distribute again. It takes a little bit of work, but one thing I noticed is that everything is the same except for one small plus and minus. Now I'm talking about this minus and this plus. So if I look at this as this being one term, the x minus 2, and the 3i being another term, then we have the difference of two squares. So multiplying the difference of two squares gives us a very nice pattern. This x minus 2 will get squared, and then we'll subtract 3i squared. Foiling out the x minus 2 squared, we know that's x squared minus 4x plus 4. And 3i squared is going to be 9i squared. Simplifying this last one bit, x squared minus 4x. And then we have to deal with the plus 4 and the minus 9i squared. We know that I squared is going to be negative 1, so this minus 9i squared is really plus 9. And plus 9 plus 4 makes plus 13. And that's the entire polynomial.